morning, good afternoon, good evening, depending on where you're joining us from. I'm Melanie Lang, and I'm excited to be back here today as your industry track lead. I also have Liza Allison here with me as the digital ambassador, so she'll be helping move things along as well. Hi, Liza. Thanks for joining us again. So we're here to help you if you have any questions along the way, and we will be introducing the presenters and look forward to getting us started. So without further ado, I would like to welcome Samantha Snapes to the stage. She has a really impressive background, and I'll let her tell you more about herself. But she has been a social entrepreneur in residence at NASA, where she also served as deputy strategist. And now she's the co-founder and catalyst for Re3D, where she facilitates connections between printing at the human scale and or using recycled materials to access locally driven manufacturing in more than 50 countries. Samantha, thank you so much for being here with us today, and the floor is yours.
Thank you so much for having me today. If you can bear with me here, I'm just going to go ahead and share my screen. Liza taught me the trick today. And apologies for the background noise in advance. Oh, shucks, what did I do?
Samantha, you're on mute if you're trying to say something.
So I'm seeing an infinite number of windows when I go to share. Let me try this one more time. Sorry. I promised you we practiced.
That's okay. When your infinite number of windows pops up, you might want to just drag your PowerPoint into that screen, and then
Is that what happens?
Yeah. If you just pull up your PowerPoint, we should be able to see it.
Okay, so how do I drag it in though?
Can you minimize your Internet Explorer?
Oh, minimize. Okay. No. Yep. Maybe not.
Yeah. All right. Well, if you want, if you shared your presentation into the Google Drive, I can share it for you.
Hey, give me 1 second here. Let me try this one more time. Let's see what happens when I click entire screen instead of window. No. I'm curious.
Yes, that's it.
Okay. I can't see you guys, but I'll just click out of this when I get done.
All right. You're all good.
Appreciate the grace, friends. So I just want to say thank you so much for the opportunity to share with you all today and our experiences being Re3D, which is the name of our company, 3D printing from garbage, which we really see as a community-led effort. For context, I think it's always helpful just to quickly share our bias. There are a number of people in this space thinking about 3D printing from waste. Some of them may be you. We'd love to include you in your examples in future talks. So how we got into this is while we were working at NASA Johnson Space Center, my co-founder Matthew and I were volunteering with Engineers Without Borders, NASA Johnson Space Center. And what really struck us in the communities that we had the opportunity to get to know in Rwanda, in Nicaragua, and rural Mexico, is the people we met were really inventive and creative. I had seen here, I was trying to teach some kids how to fart with a blade of grass. And what I thought was a musical instrument, they repurposed into other things throughout the day, which just blew my mind, for example. But we also noticed there was a frustration around the dependence on individuals like ourselves that were really well-intentioned to help bring in resources. And what we heard is that, people were in areas where there was high unemployment and long supply chains or dependence on aid really wanted to solve their own problems. And so with that in mind, the 3D printer, movement has been going on for decades now. But what we started to learn as we started to think about 3D printing as being one more tool to maybe allow some of our friends to innovate locally is when you looked at heat maps of where they weren't often in the communities that we were working in. And some people would surmise that that's due to lack of a consistent power source. But what we also heard is one, maybe the printers weren't big enough to print functional goods they would need. And also they were dependent on imported feedstocks as well. So with that in mind, Matthew and I started to think about the FDM printers in 2009 to 2012 that were open source, that were coming online. And with that bias, we started to think about what it would look like to get a polymer-based solution into these communities that was open source that could eventually be powered by waste. So to push this idea, I made a little green toilet one of the very first printer bots that Matthew got on Kickstarter to try and pitch this idea of sustainably being able to make a composting toilet, which actually doesn't look like that, or anything that was 2-foot cubed. So for our focus and thinking about waste, we're really thinking about large things, particularly things that can bear a load or be a functional and integrated part of society. So it kind of comes in between that desktop system and the larger industrial systems, some of which do print with flake. So we came up with this idea for Gigabot, which originally was a filament-based printer in its native form that we launched on Kickstarter, and put it on Kickstarter, and it was funded in one day. Nobody in Muganero bought it, but people in 23 other countries did. And what we learned is that people everywhere are problem solvers. So we started to learn with that community about all of the traditional applications, many of which have been presented at this conference, that people are using 3D printers for. And then also going a step further and thinking about where function is. In parallel, we had a 1 for 100 program whereby we give away 1 printer for every 100 we deliver to someone trying to make a difference in their community. And that was interesting because it exposed us to different needs and requirements. And many people knew that, we were really focused on not only making these large affordable industrial printers, but we wanted to print from garbage. Particularly, we really wanted to focus on printing from initially we were thinking about materials that had been extruded from waste. And the reason we did that is in all the communities that we initially had highlighted, plastic waste we saw as being a problem. Oftentimes it was being burned or it was lying on the ground. But what we learned later is that same plastics problem is shared wherever you are sitting today. Many of you have probably heard the stat now that less than 10% of plastic waste is reclaimed. Seen here are 3 images taken from outside of our office in San Juan, Puerto Rico. So initially, we really went into this with a bias towards consumer plastic, particularly plastic from landfill. And so we made a filament-based 3D printer and started looking, as have multiple other people in this space, such as Philibot, about the opportunity to extrude waste into filament. And then there's been some great groups, many in the Netherlands and other countries, as well as even in the USA and Canada, that have found ways to take landfill waste and other forms of consumer waste and put it into filament. We started our company through Startup Chile in 2013, and so we also got to know these gentlemen from Quactus that were making filament from bottle caps. So it seems like, and you can see a Philibot in the background there behind these guys, that a number of groups were coming up with hardware to take waste and extrude it into filament. But when we started circling back to those early customers that we had, what we found is when you print at scale, sometimes this filament in the bench level, the DIY version, it may be a little bit bumpy or inconsistent. And that becomes a problem when you're trying to print continuously for days. So in parallel at the same time, this amazing gentleman named Dirk van de Kroes, who has an awesome soundtrack to his videos, started sharing this robotic arm that he had customized that actually allowed him to take ground up waste. In this case, early on, it was like refrigerators and electronic waste, and then to extrude it to make beautiful items that would sell for high value. And so that got us thinking, maybe there were already people in the community that were able to have hardware to extrude filament locally. If you're printing smaller objects, that works well, or consistently for larger format applications. But maybe where we could come in was to take Gigabot a step further to print directly from shredded plastic waste in its current form factor. So we started pitching that. Some of you guys may have had to listen to prior talks where we're continuously raising R&D funds and pitching for community support with this vision. We wanted to grind up waste into granules, similar to what Dirk did, pour it into Gigabot, and then be able to print something that could be ground up and repeated. Now, people are quick to point out all the reasons why this is difficult, and we acknowledge there are many, but this was the idea. And what's really cool is thanks to the National Science Foundation, we received about $2 million, as well as about $1.5 million from pitch competitions that allowed our team in Houston, Texas, to make what's informally called a pellet printer. Many people refer to this style of printing as fused granular fabrication, whereby you have an extrusion screw you might recognize, say, from injection molding, or similar to what you might see inside of a Philibot, and it's mounted vertically, and that pushes plastic through. Now, our system in the native format, which is what you see here in the beta, is gravity fed. You also have the opportunity to use active feeding if you'd like. So what's cool is from our perspective, being open source and having this filament-based 3D printer that we modified over the 5 years before we began this research, is it gave us a broad community to pull from. And we started to form a lot of the requirements around our experiences in Puerto Rico, because we couldn't think of a better case study than on an island where landfills are reaching capacity, where there is high unemployment, and things have to be shipped in. We also happened to open that location the same year that Hurricanes Irma and Maria hit. So we were thinking a lot about disaster response and resiliency and helping support new economies. Now, first, many of our prints and the few that we've published on, unfortunately, are not as functional as maybe an ideal end case. We made a lot of skateboards because we've had interns on this project with our student-based research, but we have been able to take flake and pellets and to extrude objects that at least have shown the potential for a value add. And you'll also notice too, and just to point it out and to acknowledge what you see often in the industry, when you think of pellet printing or even pellet printing from waste, a lot of times you're going to see these parameter prints. That's because the pellet printers actually don't allow you to do retraction. So you do have to think about 3D printing in a new way. And there's a huge learning curve with that, but it is happening. What we tell people all the time is it really comes down to motivation. As you go a step further in the pellet printing conversation, then you start to go beyond just making parameter prints or things for Facebook. It really requires a lot of rigor, especially with regrind. So you'll see a lot of calibration cubes. They may not all look beautiful like you see here, where we start to really align ourselves with academia to think about all the necessary modifications to do this in an industrial application. There's also a lot of dialogue around part cooling. One of the sample prints Re3D makes is these duodecahedrons. I can't even remember how we settled on it. But you can see, depending how the cooling is and the orientation, again, thinking about 3D printing in a new way, there's a lot of opportunity for improvement. You'll see us do cylinders as well as a common torture test. And, in this domain, I would submit that we're also trying to figure out, besides the ASTM standards, what the best prints are for demonstrating pellet printing. So typically what we all do, particularly when we're thinking about regrind, is we walk through this process. We start off with flake that's ground up from a source. And I would back up, and I'd like to pause here and say, while we focused a lot on consumer plastic initially and landfill waste, what we started to learn in our studies is some of the biggest contributors to landfill are actually manufacturers. And that's why Ellen MacArthur and so many foundations are focused on waste diversion. So seen here is a polycarbonate die-cut skeleton. I happen to be an Air Force reservist, and you probably have a driver's license or identification card. All of those are made in Austin, Texas. They're stamped out of a piece of plastic like this from polycarbonate. So we had an opportunity to get 2,000 pounds of this to see if we can make waste turn into something locally. So we ground up 2,000 pounds. You can see some pictures here. And then the first thing we do is just to see if we can get it to extrude at all. We call them little poops internally. There's probably a better term for that. But in the industry, that's basically what we all do. And then after you make a little poop, you start to look to see if you can draw that bead and actually start to form a shape. Again, oftentimes it's a continuous line print. As you dig into it, though, there's a lot of science that goes into the regrind, thinking about the size that's feasible versus not, whether you can use dust or you have to focus on larger formats. And we've also learned that not all trash is equal. For example, water bottles have different thicknesses. Some curve, some are more flat. So there's a lot of science even in the granulation and the sifting that may be needed. We've also learned, particularly with water bottles and some of these tougher manufacturing forms of waste, is you may have to deal with crystallization, like real chemistry can happen in there, or it may have char from an additive. So we started to work a lot, particularly on assistive feeding mechanisms to help cope with challenges with flake. So we have some research right now around what we call a crammer, and we're also looking at using vibration motors as well with the University of Texas. How a lot of our peers have overcome this is by focusing on larger nozzle sizes, right? So by printing with a bigger bead, sometimes you can overcome some of these challenges. And then also looking at things, where you can do that continuous line, whether you're using a gantry system like ours, or it also a need for a dual extrusion system. That's not something we've been able to dedicate research to, but some of our peers are thinking about. So what you see a lot of us doing right now is really focusing on more like the home goods applications, just to get prints out there in a natural environment to get feedback. Now, the prints that you've seen here, we actually made with our collaborators at the Habitat for Humanity Restore in mind. We initially wanted to think of not only what we would make that would just sit in our showroom, but what we can make to get out to try and get sold initially to see what real value we could create. So we launched a collection last summer during the lockdown in Austin, made a series of benches that were not super comfortable, And we got a lot of feedback from the community that maybe they weren't so practical in like a studio apartment. But we launched that collection and we raised about $500 for Habitat for Humanity. Just this past December, you'll see online on our website, and we can share some links, or Charlotte can put them in here. We launched a second collection where we started to look at, you know, the initial housewares and vases and form factors we made with the regrind from the Restore, and then starting looking at more refined products. We've also formed an alliance with Canon. Canon actually makes a pellet that comes from your 2D toner cartridge. And what's so cool about that pellet is not only can it be print with Gigabyte, but it can turn materials a different color. So I could have a black print on this bench by adding a 2D or adding a Canon pellet to it. So there's a whole push now around flake and regrind and looking at maybe combining two materials, either as colorants or to reinforce or to overcome some of the limitations with materials when they're only one source. So here are a few objects, you know, we reprinted in the home kids category for the Restore this last December. And one thing that we learned along the way is, you know, there's opportunity to, again, not only just make a print, this is printed from red Solo cups, from closed loop plastics with filament, but to start to combine it with like waste that another organization already has that's low value, such as planking seen here that may have only sold for $1 or $2 per sheet. Or looking at furniture donated by 4 hands to the Restore that was missing the top of it, or insert. So we started to look at, you know, could we print things at scale that are strong, that could create value from something that otherwise would have lower value. What that also has demonstrated to us is that we need to have bigger and bigger form factors. When we think about printing from waste, people really start to think about throughput because there is so much waste, and there's a lot of engineering that goes around it. And then one thing that's come up, and particularly for us in the pandemic, is that not everyone has room for all of the granulation and other equipment that goes from printing from waste. So we started to draw inspiration from mobile recycling facilities such as Trash Presso by Miniwits, if you check them out. That focus on like molding and pressing flake, as well as the precious plastics community. Some of you guys may have come across who are really awesome. So during the pandemic, we did a feasibility study for the United States Air Force Academy with what we call the Giga Lab, which would be an opportunity to process all the waste in a container that can be powered off grid. And we're now doing that for the Puerto Rican Science and Research Trust as well. We're really excited to see where that goes this year. Charlotte is leading that, and she's in the conversation today. But what it points to too is, you know, you can have all the hardware, but there's so much science that has to be done and so much thought around the type of waste stream you have access to, the processing, the collection, the sorting, the academic rigor and the science that's needed, the training, as well as accessibility, whether it's in a container or it's not, that it's a whole ecosystem of micro stakeholders, whether it's us or another company trying to 3D print from waste. So why would we do it? I just want to close on this. So this is one of our very first, actually I think it was our second Giga Prize winner. This is Togo Chuo Clinton in Nigeria. Some of you guys may have come across his foundation called the Clinton Foundation. He actually took his very early Gigabyte that he won and modified it to print from waste himself. He couldn't wait on us to do our research because he didn't have access to the feedstock. And that's been able to help him train other students on not just starting a company, but getting them excited and motivated about technology to learn how to 3D print in general. It also offers the opportunity to provide sustainable production. So Matt Rogi was one of our early inspirations as well from Tech for Trade. He had a project in Tanzania where they were able to create an economy around taking water bottles and creating value and actually measuring the value that's created along the ways in their community. We've done something similar in Puerto Rico. We started to ask people in Puerto Rico what they wanted to print from waste. And what we heard is there was a need for buckets, if you will. So coffee farmers sometimes have to pick coffee beans with a Home Depot bucket that they'll fill too much and then it bruises the bean. So farmers asked us to come up with something that was more comfortable and hold just the amount of right of bean so it doesn't get bruised. We'll be making those objects and others with water bottles with our Giga Lab when we go to Puerto Rico, as we think about, you know, what people really want when we think about shorter supply chains, as well as continuing conversations around disaster resiliency. One of the first objects that's brought into communities when there's a crisis, whether it's a refugee or a camp for displaced persons, or in disaster response, is water bottles. We think that those water bottles could go from being trash to treasure. So now we'd like to turn it over to you, find out what you would print. Again, this was just on the polymer and flake side. There's a whole host of other people thinking about printing from waste I'd love to chat with you about, but I hope this gets you excited. All right, I'm gonna look over to the chat. Hope you can still hear me too.
So
I'm
much.
watching the time here. I was trying to keep it around 20 minutes-ish. I think we may have a couple minutes left.
Yeah, can you hear me?
We are hiring.
So I don't know if you can hear me, Samantha, but I was going to go through some of these questions in Q&A for you.
Yeah, please do.
So it looks like one of the top ranked questions was, what inspired you to go down this path of recycling and social responsibility?
Yeah, so it was really, so two things. One, I was volunteering with an organization also called Opportunity International that was doing microfinance outside of the US. And then Matthew and I volunteering with Engineers Without Borders, NASA Johnson Space Center. And it was in particular, there was a couple of trips to Nicaragua and one to Rwanda that was really formative. And one of the things that struck me the most was we were visiting a hospital that we had supported in a previous project, and I saw mounds and mounds of medical equipment just sitting in the sun that's like high value. And I was like, what is this? And they're like, oh, these gringos brought it in. It was the wrong voltage. It couldn't be maintained. It's poor cultural fit, the usual list. And they're like, yeah, it'd be great if we could just make it ourselves. So one of my first jobs was in a factory in Detroit. My family still works on the line. Matthew's a farmer from Iowa. And, we used 3D printing and former ventures and NASA, and the open source movement was standing up. So that was really the catalyst where we're like, why can't people just have one more tool in their toolkit to assist them with problem solving? And why couldn't they do it from waste? Because everywhere we see, everywhere we went, there's garbage. That's something everyone has access to. So that was really our motivation over the last 10 years.
So I think we do have time to, and I'm actually going to combine these two questions. They're kind of relevant. So when working with landfill waste, do you have any issues with either, number one, separating plastic types, or number two, worrying about cleaning the materials before it's ground and used into printable granules?
Yeah, and that's why too, what drove us to step back and focus on manufacturing waste first, because we'd heard that we just started encountering all those issues. And so one way people overcome it is some of our peers in the community, they'll use that bigger bead. They also might add a compatibilizer to help with the polymer degradation in there. There's a lot of science that really goes into the screw too. We're hoping that, in the ideal scenario, you don't need a different screw for every type of waste. The other way that people overcome it, like Matt and some other groups have come up with some interesting, in Tanzania and the DIY systems, like baths with oil or water to try and help remove adhesives or whatnot. For us, for consumer, we've had success with plastic bags, and then really starting to think about water bottles. I think we can share this. Hopefully I don't get an angry email afterwards, but we were just told today that our Credo was approved with Oak Ridge National Laboratory. We'll be working in conjunction with our NSF work on a granulator specific for water bottles, because one of the biggest issues is not just the adhesive on them, it's that they all have various amounts of water left in them. So you'd actually be able to chuck the thing in. Maybe you just have to remove the cap and the ring,
right?
Or maybe you don't, and it would grind the whole thing with the water, and then use the water with gravity separation to distill out the plastic. I would highlight too, there is another step with drying. So sometimes that you can use the drying step to help with some of these issues as well. But short-term compatibilizers, a lot of separation, or printing with a bigger bead.
Gotcha. Great.